Mr. Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Here we have lesson 20.1, exploring what makes triangles congruent. And if you recall, in lesson 18.3, we looked at something called CPCFC, which stands for corresponding parts of congruent figures are congruent. We're going to switch that F, which stands for figures. We're going to be dealing with a specific type of figure or shape, and that is triangles. So here in the first part of our notes, we have CPCTC, right, which everything stands for the same exact word in CPCFC except for that T. The T is triangles. There's two statements here that are very important, and if you want to combine this into one statement, you're going to see that in a couple pages. So our first statement is, if two triangles are congruent, then the corresponding parts of the triangles are congruent. That means this is the given. If we're given that the two triangles are congruent, then we can conclude that all of the parts are congruent, right? Because just saying the triangles are congruent, that's just a single statement. And it says nothing just from that part. It says nothing about the sides or the angles. And because I just mentioned it, parts, when it says corresponding parts or congruent parts, that refers to the three angles and the three sides of a triangle. So that means there's 6 parts total. In the second statement that we have here, our given is if all corresponding parts are congruent, then the triangles are congruent. All right, hopefully you notice something about both of these statements here. If the two triangles are congruent, and here, then the triangles are congruent. On the first one, then the corresponding parts of the triangles are congruent. Second one, if all corresponding parts of two triangles are congruent. The exact same wording that's used, it's just they switched the if and the then, right? We call it the converse when we switch those parts. On page 991, we have a vocab word here, which isn't going to be that important that you remember, but it tells us how we're going to combine the two statements you just saw. A biconditional statement, right, is going to combine the two statements by using this phrase, if and only if. And that allows you to go both ways. The if and only if means you can treat the first part as your if, or the second part as your if, which means the other part is your then part. Okay, so here is our statement. Two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. All right, to make that shorter, they could have just said corresponding parts are congruent. So two triangles are congruent if and only if corresponding parts are congruent. And remember, that's 6 total parts from one triangle, 6 total parts from the other triangle. On page 992, we're going to apply one of those statements. And it's the statement, if all the corresponding parts are congruent, then the triangles are congruent. Right? That's the CPCTC. It's actually the second statement on that first page. So in this your turn, both of these your turns, we want to determine whether the triangles are congruent. So again, we're going to use CPCTC. If all these 6 parts here are congruent to all the 6 parts here, then we can say the triangles are congruent. So let's just look at all the parts. Angle R, is that congruent to one of the other angles? Right, it's congruent. It's actually congruent to 2 angles in the other one, but we just pick one of them just so we know what corresponds to what. So I'm going to choose W. You could choose U in that case, but for angle T, you have to choose the other one that you don't use, since those all are 71 degrees. They have the same measure. but angle S has to be congruent to angle V, right? That's 3 parts so far, 3 pairs of angles. Our other 3 parts are the sides. So if I choose side RT, okay, what makes this easy if you did the angles first is RT are these first 2 that I used, which means WU is going to be the side that it corresponds to. WU. TS, okay, if you look at the angles, TS corresponds to U. Whoops, I wrote an angle there. UV, and RS is our last part, is congruent to WV. Okay, again, I referred to these up here, right? R is W and S is V and all that, so I knew exactly what letters to put for my sides. I didn't even really look over here, but it should match still. So like TS and UV, you can see they both have the 1 mark, right? So know how to verify that on the picture or through just the use of these congruence statements. So we have all 6 parts. If all 6 corresponding pairs of parts are congruent, then the 2 triangles are congruent. Triangle RTS is congruent to triangle WUV. The order of this is also important. Remember, we call this a congruent statement, just like these other ones. This is the triangle congruence statement. If you had to write any of these at all, I want you to write this one, because these letters are written in an order where they have to correspond by letter, in order. So R corresponds to W, T corresponds to U, S corresponds to V. So I'm actually okay if you don't write all of these 6 parts here, but know it. I need you to know that. If you write just this, and if it's in the right order, that is plenty. Right, so I'm writing yes because that means yes, the 2 triangles are congruent, and there's our congruence statement. Number 5, take a look at that, think about it. Are those 2 congruent? And hopefully you notice that we do have some parts congruent, but not all. So angle D is not congruent to angle G. Angle B is not congruent to angle E. And they're also not congruent to each other, right? Like angle D is not congruent to angle E, right? B is not congruent to G, that sort of thing. All we have is 2 pairs of congruent parts. And you can even list them. You can see that it is, I'll write it down over here on the left side. It's only angle C and angle F. That's 1 pair. And the other pair is BC is congruent to EF. And that's it. So only 2 pairs of congruent parts means that it's no, not congruent. Now we're going to apply our other statement. It's the very first statement on the beginning of the lesson. And that is, if we know the triangles are congruent, or if we assume they're congruent, then all of the 6 pairs of corresponding parts are congruent. In this, your turn, it tells you that it wants these to result in congruent triangles. So we're just going to assume they're congruent, and we need to find the value of the variable. The variable in number 7 is x, and it's this angle right here. X plus 17 is this angle. So what does that correspond to? It corresponds to angle B. So those are congruent. So I'm going to put a little mark here at E and one at B. Because G is congruent to D, and then F is congruent to C. Now in this particular problem, you have to know the triangle sum theorem. I'm not going to write it out completely, but the triangle sum theorem says that if we have any triangle, any triangle, doesn't matter, all the 3 angles inside add up to 180 degrees. Okay, let me repeat that. Any triangle, right? Anything with 3 sides that's closed, it has 3 angles. All the 3 angles always add up to 180 degrees. Remember, this only applies to angles. I do sometimes see some students apply this to sides and think that sides has something to do with adding up to 180, and that never happens. It's, in fact, I shouldn't say never. It could, I guess, but very, very rarely. But the angles will always add up to 180 in a triangle. And that's going to help us in this problem because we have 2 angles in this triangle BCD. We don't have the third one. In order to find that third angle, we just take 180 minus the other 2. Right, 112 and 25 add up to 137. So that leaves 43 degrees left. So that means angle B is 43 degrees. And then angle E also has to be 43 degrees. But I want to know what x is, so we use this x plus 17 expression. And that is supposed to equal 43. If we subtract 17 on both sides, we'll get 26. And that's the value of the variable. Okay, number 8, if you'd like to pause it, go ahead and pause it. Try it out. This has to do with sides and not angles this time. Okay, I'm just going to go ahead and do this problem. Our variable y is side jk, right? 4y plus 12. And that corresponds to this side over here, mn. You can tell by looking at the angles. So this angle here, angle k, and the angle n correspond. J and m correspond, right? J and k, n and m. Or mn, I guess, going that way. So if those two have to be congruent to each other, since we're assuming the triangles are congruent, then the measures are equal, and that allows us to set up our equation. 4y plus 12 equals 32. If I subtract 12 on both sides, we get 20, and then divide by 4 gives us y equals 5. Usually these problems, solving the equation isn't going to be too difficult. It's just knowing how to apply the CP/CTC. Just know what corresponds to what to help you set up your equation, and then you just go through and you solve it. Okay. I wanted to show you one of the problems in the assignment, how to go about and approach it. Number 10 on page 996. This is going to be the same as the next 3 problems after this, but we want to determine whether the given triangles are congruent. So if they're congruent, remember, we don't know they're congruent, so we have to use that second statement on that at the beginning of the lesson, which is if all of the 6 pairs of corresponding parts are congruent, then we know the triangles are congruent. So what makes this difficult is they don't give us a ton of information. They just give us 63.4 degrees is this angle A, 26.6 degrees is this angle F. But the fact that it's on a coordinate plane allows us to find more measures because it makes this thing look more precise. And what I mean is this horizontal part AB, we can count that. That's 3. And ED is also 3. Right? We can also count BC and we can count EF. Now we cannot count AC. So think about how we find that length. And it's going to be the same for DF. We have to use distance formula. There will be a little bit of work into this, but you just want to show that they're both equal to each other. So you don't even really have to calculate the whole distance. As long as you get something where they look equal, that's fine. Make sure you're showing that. Now the angles, haven't talked about those yet. Obviously 63.4 isn't equal to 26.6. So we're hoping that this one over here is 26.6. This one over here at angle D is hopefully 63.4. Now we know what angle B is. because anytime we have a horizontal and a vertical line intersect, it's going to create a right angle for us. So that's 90 degrees. If that's 90, then we know that 90 degrees plus 26.6 degrees plus whatever angle D is going to equal 180. Okay, you don't have to write this all down, but I'm just showing the logic here that the three angles in that triangle have to add up to 180. So use some subtraction to figure out that third angle. And then you're going to do the same thing here, right? And hopefully these here will match up with these here. Let me talk briefly about number 11, because number 11 actually looks like they're not congruent. And that means we don't have to show all the parts, and it's going to be difficult to get some angles here. So focus on the sides, just because it's, we can find distance very easily. Just apply that formula. We can count what this is. This is 4. So over here on LKM, if we show that none of these are 4, none of the 3 sides, there's no way this can be congruent to this. So it's almost like showing a counterexample. And so this may not take as long as some of the other ones that are actually congruent. Right? Remember, right now we only know if 2 triangles are going to be congruent if all 6 parts are congruent. This will become easier. We'll need less information kind of as we go through this unit. Okay, that's going to be it for this lesson. Thanks for sticking around and watching. Hope you have a great day.